Before we begin, though, we're going to need a volunteer from the audience. Someone that doesn't mind coming up on stage and having a little fun with us. Just go ahead and raise your hand.
By the way, this is real. We don't have any moles in the audience, so.
All right, Matt's going to go and pull somebody up.
Excellent.
Well, as you know, FPGAs are a hot technology. They allow hardware to be rewritten in the field rather than costly chip respins for every logic change. In the past, FPGA programming required difficult-to-use text-based languages. Well, a few years back, National Instruments introduced LabVIEW FPGA and introduced test and measurement engineers to graphical FPGA programming using LabVIEW. This allowed a broader range of scientists, engineers, and students to design their own custom DAC hardware. Well, today we're taking that ease of use one step further with the introduction of the LabVIEW FPGA Wizard. Let's go ahead and see how it works. Up on the screen here, we've got a project with a compact Trio controller and 4 modules in it. We can start the FPGA Wizard by right-clicking on the target and selecting the option to start it. The FPGA Wizard is designed to get you up and running with your compact Trio target or R-Series board quickly. It generates a complete FPGA diagram along with a host shell that handles the communication and synchronization. On the left-hand side of the screen, there's a configuration tree where I/O can be organized underneath of timing engines. As we create a timing engine, we can select different options. In this case, we've created a timing engine with an internally generated clock running at 4 kilohertz. We can then go on to add additional I/O, such as analog input, or more complex I/O, such as pulse width or PWM generators or edge counters. For each of these items, we can select resources from the available FPGA I/O in the project and select other options, such as count direction or polarity. After we're done with the FPGA, or with the configuration, we can go ahead and save it. And we can create multiple PWM generators by simply right-clicking on items and selecting to duplicate them. Let's go ahead and take a look at that generated code, though. All right, the FPGA has now done in minutes what used to take days, potentially, of programming. Over on the left-hand side, you can see that the FPGA Wizard generated all the code necessary to both acquire and calibrate your analog input data. It's also dropped all of the logic necessary to create the PWM generator and the edge counters. The timing loop has an internally generated clock, and data is being synchronously passed back to the host using interrupts. This is a fully functioning FPGA diagram. However, we can go on and add our own custom logic or filters. In this case, let's go ahead and add the new Butterworth filter ExpressVI. There you have it, a complete diagram using the FPGA Wizard. I'd now like to go ahead and turn some time over to Roger for another demo on what we can do with the FPGA.
Hold on, Roger. Before you get started, let's go ahead and meet our volunteer. So, hi, how are you doing?
I'm okay.
And we have never met before, right?
Yes, that is true. This
Okay.
is not a plug.
Okay. And what's your name?
Norm Kirchner.
And you're from?
From Dallas, work with Texas Instruments.
Texas Instruments. And you're a LabVIEW user?
Absolutely.
How long have you been using LabVIEW?
Since about 2000.
2000, okay. All right, well, let's let Roger explain the demo, and then we'll get to you in a minute.
Thanks, John. To push the limits of FPGA timing, synchronization, and data transfer, and to try out a few of our latest features, we decided to make a slightly unconventional demo.
That's where you come in, Norman.
Yes.
Why don't you head over to Dustin, and he'll
Like
tell
our
you what to do.
volunteer here to help us
Right
try it
that
out.
way. Yeah, Dustin.
Okay. You're going to jump over on this pad? That one over on
That
the
one
left?
over
Yep. I'll start the game here for you. And what's going to
Start
happen
you on the easy level.
He really doesn't know what he's in for here.
as you start, the arrows go up. You want to step on the right arrow? As it hits
All
on
right,
the
What
Roger.
we've made,
one on the left. You got it.
you guys can see what it is. This is an arcade-style dancing simulation game, like the popular Dance Dance Revolution, with LabVIEW FPGA and the 7833R. This song you're hearing is a stereo 44 kilohertz audio stream playing through 2 analog outputs on the 7833R. We're DMAing this audio data from the RT host down to the FPGA using the great DMA output feature that we recently released. For the video, we're using another DMA channel to stream down 40 megabytes per second worth of raw video data that you're seeing on the background. At each pixel, we make over 330 calculations to pick the right red, green, and blue color values. And for the resolution we're running at, This means that we're making over 13 billion calculations per second on the FPGA. To handle communication with the dance controllers, we've implemented a custom digital protocol, which tells us which arrow on a controller is being stepped on. This feeds into a high-precision scoring algorithm that's synchronized to the song and the on-screen cues with pre-recorded step data. We're using our new native FPGA memory blocks to store this step data. There are 10 parallel loops running on the FPGA to affect what we see here, making this demo a fun way to showcase what this great product can do.
All right, good job, Norman. Now, Roger, hold on.
We're gonna need
We're
you
not
for
quite
one
done.
more.
Roger, I couldn't help but notice that he was kind of getting it towards the end. So maybe you could,
Okay.
you know, show him the, crank it up a notch.
Yeah. You ready?
You've been practicing all weekend.
Oh, I have.
So Roger is involved in building this demo. So.
Not bad.
I saw him miss. He missed once. All right. Good job. Now you're done. Okay, thanks, Norman, for being such a good sport. We have the first hot off the shelves, literally got it this morning, LabVIEW 820 t-shirt, complete with our tour stops from every version. And that's yours to keep. Thank you.
Thank you very much.
Good job.